Today we are going to be looking at percent change, and just to warn you ahead of time, these problems do tend to go really well with word problems. So look forward to that because I know how much you all love word problems. But today we're just going to look at the nuts and the bolts of it and how to actually do these percent change problems before we start getting into the actual applications of them. So first thing we'll do is look at finding a percent change. So let's say that we have some number that is changing over time and we want a measure of how big those changes are. Because sometimes just the absolute number change isn't good enough. Because if you think about it, if I've got say $10 and you give me $2, then that's a pretty big difference right there. I've gone up by quite a bit because I didn't have much to begin with $10. But if I have $1 million and you give me $2, it isn't really important at all. And comparing things by percent change lets us notice that. Okay, so to find percent change, we're going to use the following formula. We're going to take the new number minus the original number, and then we're going to divide that whole thing by the original number again. So you got to keep track of what is the new number and what is the original number, because we have to do it this way. And we're always dividing by the original number, so that's very important. If the number is positive, so the new number is bigger, then there is a percentage increase, and if the new number is negative, that means that the new number was smaller and there was a percentage decrease. So let's look at a few examples of this. Okay, the first one, let's look at how big the percent change is if we go from 100 to 120. So I'm just going to throw that in my formula here. My new number is 120. My original number is 100, so that shows up twice. I do the subtraction first in the numerator, and I get a 20, and then I divide that by 100 to get 0.2. But we know, because of our work with percentages earlier, that 0.2 is the same as 20%, and because that number was positive, that means that 100 to 120 represents a 20% increase in value. Okay, let's look at another one. Let's go from 25 to 20. So our new number is 20, and then our original number was 25, so that's the one that shows up twice. So we do the subtraction in the numerator first, and we get 20 minus 25 is equal to -5. And then we have -5 divided by 25, which gets us -0.2. And again, 0.2 we know is 20%, but this time it's negative. Our number went down, so this is a 20% decrease. All right, here's one for you to try. Try to find the percent change going from 40 to 30. Okay, so you take 30 minus 40 over 40, because our original number was 40, so that's the one that we used twice. That'll get you -20 or -10 over 40, which is the same thing as -0.25. We know that 0.25 is the same as 25%, and it was a negative number, so we have a 25% decrease. And then finally, here's another one for you to try. What is the percent change from 1,000 to 1,100? Okay, our original number was 1,000, so that's the one that we used twice. We go 1,100 minus 1,000 gets us 100, and we divide that by 1,000. So that gets us 0.1, and 0.1 is 10%, and because we were going up, our number is positive, and what we have is a 10% increase. So if you know the two numbers, just use this formula, and if it's positive, you have an increase. If it's negative, you have a decrease. So just use this and find the percentage. But sometimes we want to find the new number. So we're given some percent change, and we want to find a number that represents the new one. And when I said that these lend themselves really well to word problems, think of this as like a tax problem. If I buy something and there's an 8% tax, then what I'm doing is increasing the number by 8%, and that's the new price that I pay. If I go to a store, and if I go to like the mall and there's a clothes store and there's a sweater that's 20% off, then I'm taking a 20% decrease of the original price. So that's where this really comes into word problems. Okay, so to solve this, we are going to set up an expression, and then we might combine some like terms, and there's a couple different ways that we can do this, and I'm going to show you both ways. So if it's percent increase, you will be adding a like term, and if it's percent decrease, you will be subtracting a like term, which should hopefully make sense. If we have decrease, our number is getting smaller, and if we have increase, our number is getting bigger. Okay, so let's look at this one. Let's find 40% more than 50. So what we're going to do, this is 40% more than, so it's an increase, so I'm using a plus. And the way I'm going to set this up is I'm going to say that this is 50 plus 40% of 50. And remember, when we're talking about fractions or percents or decimals, the word of always means multiplication. So 40% times 50. And there's two different ways that we can look at this. The first one is to say that I've got 100% of 50 and 40% of 50, so that is 140% of 50. The other way is to just calculate this multiplication first. So 0.4 times 50 is the same as 20, and we can say that that's 50 plus 20. Either way we do it, if you do 1.4 times 50 or you do 50 plus 20, you'll get an answer of 70. Okay, here's one where we want to find the decrease. So we want to find what is 25% less than $80. Let's say we're buying a pair of shoes that's $80, but they're 25% off. We want to know the new price. So this is subtraction because it's less than. Our price is going to be lower if this was a word problem. So we take 80 minus 25% of 80. And again, there's two ways that we can write this. So if this 80 is 100%, we're subtracting 25%. So that means that the new thing is we have 75% of 80. Or we can do this multiplication first, and 25% of 80 is 20. And we can say that this is 80 minus 20. So either way you like to do it, the answer is 60. Okay, here's a couple for you to try. So the first one, what is 35% more than 90? Okay, we've got 90 plus 35% of 90. So I'm going to look at this as 135%. Just by adding together. So 135% of 90, and I can change that to a decimal, which is 1.35 times 90, and just punch that into my calculator or do it by hand, either way. And you'll get the answer 121.5. And it's okay to get decimals here if that's what the percentage tells us. Okay, next one. What is 16% less than 400? Okay, we're going to do it the other way this time. So we've got 400 minus 16% of 400, which is the same thing as saying 400 minus 0.16 times 400, which we know is 64. So our final answer is 400 minus 64, which is 336. And one last one. What is 125% more than 20? Okay, this is more than, so we're adding. So we have 20 plus 125% of 20. Well, if this 20 is 100% and we're adding 125%, then we can say that this is 225% of 20. And 225%, we move the decimal, and we know that is 2.25. So 2.25 times 20 is going to get us 45, and that's the answer. 125% more than 20 is 45. Okay, that's everything for today. We'll get some practice on this in class. Make sure you ask me questions if anything isn't clear, and I'll see you then.